Okay, so we talked about vectors, the different ways to notate them. The ijk is popular just because Einstein was so popular and he loved that kind, but I I despise it. It's excessively complicated. At the very least, you could use XYZ because I've kind of trained you in cross products, which are not this chapter but much later in XYZ. Okay, so what we typically do, we'll say example 1 for chapter 4. We launch a projectile. What does projectile mean? It's a sneaky physics word. Okay, projectile actually means that there are no forces on it except gravity. Only G. We'll say little g is the nickname for gravity. Okay, and then we want to know its position vector. Maybe it's velocity vector or acceleration. Okay, but those are really easy. So, we gave it a velocity, and it might be common to say, I actually have a speed and an angle that's my direction. Well, I did give speed and direction, so I have both and I have velocity. Okay, so what do we do? Just in general, I can say my initial velocity vector, can I use the brackets, x comma y? Give me a thumbs up if you have to have IJKs because you're Einstein fans, or we used x hat, y hat, z hat last year. Okay, well then I just have v0 cosine theta for my x, because we're imagining there's a right triangle, and here's my angle, and something was fired up, and then the hypotenuse is v0. So we're in like this velocity diagram. So it's just v0 cosine theta, v0 sine theta is the y, and that's v0. Let's do blue. Better. What's my velocity as a function of time after this thing is kicked? Well, you would use our good old equation number 1, v equals v0 plus at. But what's a in the x direction? If there's no forces, exactly, if there's no forces, I said the word projectile, so there's no forces other than gravity. Well, gravity only acts down. In fact, we went on about that in first year physics. The only way we define the direction down is that's the way that gravity points. It actually points a little bit sideways. If you imagine the Earth is a perfect circle, there's mountains and things, so there's valleys so low that it starts to point out from the valley because there's more mass of the Earth on the sides, and there's mountains so big that it will start to pull like a plumb bob or a pendulum sideways towards the mountain. So the geoid, the gravitational level of the Earth is actually really bumpy. It's not a geometric circle because things are so massive near the surface. Right? Anyway, the x velocity, it just stays whatever it was, v0 cosine theta. Those are all constants. Right? And I usually give a fun, nice angle like 30 degrees or 30, 37, 36.87, whatever. So then we just have v0 sine theta minus gt. I'm going to start accelerating down. That only affects the y component. Oh, so there it went. It's like a bucket. There it went in its little bucket or bracket, and now it's got its spot. Okay? And that's because we really don't have to state the obvious. But for a projectile, we might. A is constant. So we have 0 acceleration in the x direction, and we have minus 10, or negative g. Let's say negative g. Negative g in the y direction. Okay? Well, then we can just do the antiderivative. Let's get really purple. Yeah. So I would say R equals, oh, I need to define some things. Let's make it super easy for ourselves and say x0 equals 0, y0 equals 0. Okay. That's just declaring I'm gonna start measuring all my stuff for my problem right from where I started. From where the projectile left the ground or someone kicked the ball, where it hit their foot, that's where I'm gonna start my time and my coordinate system. Okay? Well, okay. So then your x direction, x, so now we're in equation 2. And so I should have v0t. Well, it's only because the original v0 was given at an angle that I now have v0 cosine theta times t. And sure enough, okay, I have y0, so I have v0 sine theta times t minus 1/2 gt squared, or g over 2 t squared. Oh, and that's it. What else do I need to know? If x0 and y0 really are 0, then no problem. And if I've actually got, that's what your homework is about. What if I kick it like down at an angle, or someone launches themselves off a cliff for some reason? It's like a skier, or it falls out of a plane. Well, my v0 might be a negative angle that's below horizontal. That's fine. The sine of a negative angle is negative, and the cosine of a negative angle in the fourth quadrant is not negative. It still goes positive. Okay? If you strictly use your physics coordinates, where theta is always measured counterclockwise from the plus x-axis, okay, so an angle that swings down is negative, no problem. Sure, Jacob. Aha. Yeah, he missed one. Good question. Okay. What on earth do I mean by R? Yeah. The R vector is like the x position plus the y position plus the z position. Now, those are all perpendicular directions. Some physicists think there's more than there should be. Okay. But don't worry. We are going to stick to x and y until we get to rotation, which is several units down the road. Okay, we don't need z until then. So we'll just have x and y. And rather than write, so the position is a function of time. This is just fancy function notation. That's like a throwback to Algebra 1. You could write it x sub t with an x hat. We've seen that before in my class. And a y sub t, so we'll exclude z with a y hat. Just to keep them separate. Albert Einstein was really popular for some reason, and he didn't like x and y for horizontal and vertical. He liked I and j, but they mean exactly the same thing. He liked to say I hat, and I curve my eyes backwards to distinguish them from j's, and a j hat. Okay? But I think we're wasting time and writing by writing that formula, although College Board uses it, so we have to be aware of it, the IJ case. Okay. I know you're familiar with XY points, so why not just indicate all these are as X and Y categories. This is the motion that's happening simultaneously in the horizontal direction, and this is the motion that's happening simultaneously in the vertical direction. So why not just make an angled bracket to signify a vector with your X portion, comma, Y portion. Okay, so this is Vx, Vy on the velocity side. You can have AX, AY. Okay, and then here's R is position, X and Y position separately with a comma in between. I think that's the most efficient way to do it. Physics and calc teachers should be able to recognize that notation if you use it on like a free response problem. But let's see, I have actually, we've rarely seen, because there's so many notations, I've rarely seen a free response question that actually requires it. They'll usually ask for one component, and so whatever you've written down, they'll like give me the y component after 10 seconds. Okay, and then you write down the answer with correct units and number. Okay, showing a little work. Good. Any other questions? Well, okay. That should actually get you through tomorrow's assignment until number 64. We have not talked about motion in a circle. And so I was supposed to get this out of the way online yesterday, but so I'm a day behind. So we will try, I'll explain. Let's see. To keep up for the assignment, in-person people, try to solve up to number 64. It's all but two. How many problems is that? I should count. It's 1, 2, 3, 4, 5. That's do the 7 easy ones. And if you started yesterday, that's not too bad. Oh, let's stop my recording.